Logarithmic functions, its nature, key features, types of equations, and real-world application. To grasp the concept of a logarithmic function, we must first look at the exponential function. Its general form is f of x is equal to a to the power of x. It has a shape which grows exponentially and increases at a consistent rate to infinity. The graph in its general form approaches y equals 0 and y equals infinity. The nature of the graph. A is called the base and x is any real integer. Complex values result from the function if a is less than 0, so these values of a are avoided. So if we look at this formula, based on the log laws, we can rewrite this as log a to f of x equals x. So if we graph this out, we'll mark a point at 1 because anything to the power of 0 is equal to 1. It would increase to x equals infinity and y equals infinity, and approach y equals 0, as well as x equals to negative infinity. So if we write out the exponential general formula next to it, we can actually see that the logarithmic functions are essentially an inverse of the exponential graph, and that they're connected and have similar features, but except it approaches x equals infinity and y equals 0. This would also mean that the logs are exponents. So y equals log ax would actually be connected to a to the power y equals x. Y is the exponent. So if we put it next to the exponential graph, we can actually see that it is essentially the inverse. The fact that it approaches x equals infinity and y equals 0 makes this evident. It is also important to point out that x can never be negative, as y equals 0 is an asymptote. If we compare the two graphs, it is clear that they are inverses because the intersection points, which are 1, 0 and 0, 1, actually switch, and that is what an inverse is, the x and y switch in the equation. And also the asymptote switch, which is x equals 0 and y equals 0. How logarithmic functions are seen in real life. pH scale and logarithmic functions. In regards to pH scale, a logarithmic function can be used to determine the pH of a certain solution based on the hydrogen ion concentration. Acidity depends on the hydrogen ion concentration in the liquid, written as H positive. The greater the hydrogen ion concentration, the more acidic the solution. Pure water contains hydrogen ion concentration of 1 times 10 to the power of minus 7 moles. To calculate the pH, we must use a log formula as well as log laws. So to calculate this, we must use a formula, and this formula will be minus log 1 times 10 to the power of minus 7. And so we can rearrange that by making it minus log 1 minus log 10 to the power of minus 7 due to one of the log laws. So if we draw out this the reflection of this function because it's negative, we actually find out one of the points, and the point I've marked out is 1, 0. And so we can actually write log 1 as 0. And because the log 10 to the power of minus 7 is so low, it's hard to actually find a number, but we actually know it's minus 7 because it's 10 to the power of minus 7, and the base of it is 10. So it becomes 0 minus 7, which is 7. Therefore, the pH is 7. Logarithmic functions and safety index. If 1 in X persons die as a result of doing some given activity each year, the safety index for that activity is simply the logarithm of X. If 1 in 5,300 people dies each year due to car crash, or 1 in 800 dies each year due to diseases caused by smoking, what is the safety index of the statistics? We calculate this by doing log 5,300, which is 3.7, and log 800, which is 2.9. Therefore, the safety index for car crashes is 3.7, and the safety index for smoking is 2.9. Logarithmic functions can also be used to calculate population growth, magnitude, and radiometric dating.